Well, it's great to have the invitation to speak to you today, and there's one thing worse than speaking on a Friday before a bank holiday, and that's doing the after lunch slot, but we're spared that today, so excellent. The Royal Aeronautical Society is the only truly global professional organisation representing the entire ecosystem of aviation and aerospace. That's everything from blue skies research and universities right the way through to what goes on the flight deck and everything in between and wraps around it. We are therefore a learned society, but we're also a professional engineering institute. We accredit university teaching of aerospace engineering, we assess apprenticeships, and we register engineers up to chartered status. As a sector, we are deeply affected by the impact of COVID-19. You can't escape from that in your newspapers. And I'll weave a little of that along the way. But with the title of Tomorrow's Aerospace Professional, I wanted to pick up two things really. One, the generic aspects of careers and skills of tomorrow, and also the linkage that there is across the digital enterprise, if you will, between what you've been discussing previously this week and aerospace. So this is the sector in the UK, and while I leave you to absorb the numbers, I'd make the point that the convergence of technologies of the fourth industrial revolution, particularly autonomy, AI, digital connectivity and electrification, will, in my view, see aerospace and aviation being the most transformed sector. And I always typify that perhaps of getting used to walking on an airplane, looking on the flight deck and seeing nobody there. That's all in the art of the possible. And we'll all get used to that. And then along will come quantum science, which will change it all again. But this process of embracing these technologies is fraught with both ethical and safety issues, and that's particularly the case in aviation. Certifications of systems driven by potentially non-deterministic software is completely unknown territory. And it's much the same in defense, and you've got the added in defense aerospace, you've got the added complexity of having to adhere and prove that you're adhering to the law of armed conflict. So we're already finding ourselves as a society being asked the hard questions: why, when, how much, is it safe? And now we're getting similar questions about the reaction to COVID-19. And the vibrant sector shown here will suffer badly. If there is no passengers out there wanting to fly, there is no airline market. If there is no airline market, there is no aerospace market. And that's the sobering facts behind it. And currently 63% of the global airline fleet are grounded. It'll be 2023 before we see a return to 2019 levels of activity, and long haul will be bringing up the rear in that respect. So when it comes to the aerospace profession of tomorrow, there is common ground across engineering, and particularly the digital aspects you've been discussing all week. There is complexity in the systems we'll be developing and manufacturing. Competition for smart people with the right skills will be a problem. And I talk as someone who went to university armed with a slide rule and a set of log tables. Culture shift, because of differing norms, will be something that we will have to address, particularly in terms of climate change, and in the society we're developing our thinking on, well, what are the green skills of tomorrow, having just surmounted what we believe are the digital skills of tomorrow. And these things are all interlinked, which just adds to the complexity. And that's where we'll start. Here's the standard business model of a typical civil aircraft. So what can we say about that? The first thing is it's a long-term game. A lot of cash negativity up front, and that is the area of greatest complexity perhaps, because it's obviously where design development takes place, design and production, and the route to certification. It lasts a long time and it's deeply expensive. But success will pay you back. The Boeing 747, 50-year lifespan in operation, 1,500 built. It plateaued with 1,000 in service at any one time. Each of those airplanes had an average life of 27 years, and there's still some very aged 747s in service. Unfortunately, totally different for the A380. A lot more recent, of course, but again, 17 years between the initial design inclination to first delivery, which was in 2007 to Singapore Airlines. And the 380 is unlikely to survive COVID-19 in airline service, first airplane that most operators brought out of service. So COVID-19 will reduce offtakes from that already invested capital below the line, and it will flatten out the return on investment. And we can also say pretty much that model was amenable to traditional engineering and manufacturing approaches, and similarly traditional approaches to design and production and indeed the aftermarket. But that won't be the case anymore, because complexity in those areas, and particularly integration and particularly certification, and the inherent costs and lengthy time budget that traditional approaches would have made real will no longer work. And climate change technology in particular is introducing greater complexity, because in aerospace, we kind of work incrementally over the years, whereas with things like electrification, we're changing the basic rules under which we operate. So the challenge that we hear all the time is to halve the time and halve the cost of that currently long cash negative period below the line. And that's classic made smarter and Brunel challenge territory. And we've got to get it right first time. And how will we solve it? Well, digitization, of course, artificial intelligence and machine learning, robots in manufacturing for sure, and in the maintenance and repair and overhaul of the aftermarket. And I might say, accelerating into the delivery of airline services, because the only way we can make the business model work in a new normal or post-COVID world will be to be very, very efficient in the way we do all the add-ons to airline services. So we're in the era in manufacturing anyway of digital twinning for design and development, but it doesn't stop there, because the notion is that airplanes now will be designed with a virtual digital backbone, so that from the minute design starts, the generating the modeling and the data that will take it all the way through life, and will gather information about that airplane every second it's flying. It's a data-rich environment. And to make it economically viable, you have to use that data to ensure efficiency. So from the point of view of who we employ, we're going to start to need two things. We're going to need a lot more digital scientists, and we're going to need a lot more development engineers who really understand the digital science. And those are steps we're taking with the universities that we accredit right now. And so much for my slide rule and log tables. But we are in competition. Our conditions are not brilliant. We're in competition, not only attracting the right skilled people, but fishing in the right pools. We've added to the problem in aerospace because we've got too much age and too little gender diversity. The average age of aerospace professionals, that's engineers and technicians, is 49 and 3 months. And for men and for women, it's 45 and 6 months. So that's a significant issue, and that's why there is so much emphasis being placed on apprenticeships in these sectors. And then secondly, of course, addressing the gender issue, and those pie charts just show you the way it is. And we have a couple of initiatives that we run in the society. One, the Women in Aviation and Aerospace Charter, which includes government backing from BAES and the Department of Transport, and was embraced in the aerospace sector deal and indeed in Aerospace 2050, which is the government's aerospace strategy. And that charter has its own work streams, so it's a continuing live stream of activity. And secondly, and certainly it comes to us that this is regarded as really important, is our ALTA mentoring scheme. And that's been developed to allow female mentors to offer their skills to women who seek support, but in specific career or personal areas, which are often the barriers to either attracting or retaining female engineers and technicians. And these are the obvious ones: maternity leave, career breaks, work-life balance. And female mentees identify a mentor with a suitable experience and to suit their development needs. And that works really well. It's highly valued. Whilst on that subject, work experience for young females is seen as a key ingredient of their decision making. This comes from our own research on attitudes of that era. And it's quite clear that sitting behind that is this sense, well, not quite sure about the cultural reputation of engineering and aerospace engineering in particular. So it would be a good thing to be able to go and test it for myself and make up my own mind. And that's a very important part of some work we're doing now in order to produce a platform which will provide a proper marketplace, as it were, for matching work experience with employers. And the area that's generically working across engineering, which I imagine many of you have heard about, comes from the Royal Academy of Engineering. It's known as This Is Engineering is the program, and the new strapline is Be the Difference. This is aimed at young people 13 to 18, parents and influencers. And the key change in that for 2020, something I'm going to come back to, it's about societal benefit. And in schools as well, we in the society run a thing called Cool Aeronautics, fronted by Aviator Amy, a cartoon, which is pre-packaged for teachers and allows primary school students to get a real taste for the excitement that aeronautical engineering brings with it. The key about this is that one size doesn't fit all, and I will come back to that. We're also in competition with other countries, of course, and this just shows the recent OECD report, which was a wake-up call. It's based on the PISA survey. The PISA survey endeavours to determine the quality of education right across nations. As you see here, 79 countries, and particularly concentrates at the 15-year-old cohort because they're making their life decisions right now. But the expectation was that since the year 2000, the world has changed. There's this exciting tech world out there. So surely that will be acting as a magnet to young people and their career choices. Actually, not a bit of it. Very little change in career aspirations. You see the favoured careers there, and engineers, happily, are fourth, but that's pretty static in terms of the appeal. And the interesting thing is a gentle decline in ICT professionals, maybe because that's the shape of the industry has changed. The other aspect which brings us, if you like, into a new competitive environment is the transfer of intellectual property generation capability from west to east. If we go back to the year 2000 and look at the top 20 universities on the QS rating for technology and engineering, right across the piece from research all the way through down to undergraduate teaching, we'd have seen 15 US universities, 5 in Europe, 4 in the UK, Oxford, Cambridge, Imperial and UCL, and inevitably École Polytechnique in Lausanne as being European. That sort of switched around a little bit over the years. But if we look at it in 2019, we find that there are only 14 in the West, 3 of which are in the UK, Oxford, Cambridge, and Imperial, and 6 in the Far East, 3 of which are in China, Tsinghua, Peking, and Hong Kong U, 2 in Singapore, and 1 in Tokyo. The reason for that is those nations have invested heavily by central government in their science ecosystem, and particularly in research and development. So what drove me? Well, on the 14th of October 47, Chuck Yeager flew the Bell X-1, Glamorous Glennis it was called, named after his first wife, and he was always at pains to point that out, at a speed of Mach 1 in level flight. First time the sound barrier had been broken. And then on the 3rd of October 1967, as it happens, the day I went to university to read physics and electronic engineering, then William Pete Knight flew the X-15 at Mach 6.72, and that's just 20 years later. And if you're curious, the interviews are available on the National Aerospace Library, it's our library, as podcasts. But in those 20 years, which then propelled us into getting to the moon and producing us Concorde, the sector was exciting, it was glamorous, it was inspirational. And there is no doubt about that. It didn't necessarily come at no cost. Yes, there was a lot of ambition, huge national and international ambition. Yes, there was a lot of investment coming from that very competition, and a huge amount, of course, coming from government. But did we do it safely? No, we didn't. We killed a lot of test pilots along the way. It was really was uncharted territory, going from Mach 1 to Mach 6.72. But the drivers for my generation were those impulses. It was all about faster, further, higher, getting to the moon, winning the Cold War, all that sort of thing. And the societal benefits were just a spin-off that, you know, frankly, we didn't pay much attention to. I have to tell you, that has changed. Because here's our research on Generation Z, which brings together a number of streams. But out of this, I really want to just focus on the ethics and culture aspects that appear on this slide. Ethics, interestingly, in the UK, engineers are among the most trusted professionals. We're actually fifth behind nurses, doctors, dentists, and teachers. And the accent of science and COVID-19, and as you will hear shortly, the accent on engineering will play to that. But ethics, doing the right thing, for example, focusing on climate change, and culture, doing the things right, diversity, empowerment, a meritocracy, all those are in there, and that's what Generation Z look for when they are seeking a career. We've got a few things to help them on the way, and anything to do with space always catches attention of young people. And any primary school teacher will lament the fact that in terms of getting kids interested in science, you can talk about dinosaurs and they'll love it. You can talk about space and they'll love it. It's just the stuff in between that gets neglected. But it really, really is a factor in motivating young people to just take notice of what's going on in the scientific and engineering community. And the Artemis program is a great example of that. Two factors about the Artemis program. One, it's going to the South Pole of the moon. You might ask why, because that's where the water is. And we only just realized a few years ago, based on Apollo 1, or the first series of Apollo data, that there was water there. And secondly, it's training for Mars. And you only have to look back in the UK at the sort of Tim Peake effect and the galvanizing effect Tim has had on young people. He's great at engaging with them, but talking about his experience on the International Space Station. Maybe the biggest factor germane to what I've been talking about, though, is the name. Artemis, of course, as all you classically educated engineers will know, was Apollo's twin sister. And there will be a woman on the moon as part of this series. Only so far, 12 men have trodden the path on the moon. So, by way of conclusions, this shot is the far side of the moon. It came from the Chinese program, from the National Chinese Space Authority, and we provided them, awarded them a gold medal. It was an outstandingly beautifully executed piece of science and engineering. But from what I've said, I'd just make 3 points to to leave you with and conclude perhaps. It is an exciting digital world out there. There's a lot of really interesting technology which should infuse a generation, but it's how we sell it that is the challenge. Secondly, one size doesn't fit all. In the old days of my corporate life, I always felt, oh, there's too little coordination. Why does the government have one scheme or whatever? Now I'm a supplier of this. I recognize that it is actually about a patchwork to be effective. And thirdly, we have to sell it in a way that appeals to the market. And it is about ethics, and it is about culture. And for those of you who proudly own the Pink Floyd album released on the 1st of March 1973 by Harvest Records, The Dark Side of the Moon, I have to tell you, there is no dark side. It's just like the Earth. Thank you very much indeed.